We are starting with examples on database first. First we will look at some examples. Idea behind this discussion on examples is you see some real action on the database front. I will explain how they are used and then we will discuss the presentation. Session 16. Now I have created many programs on database. If you see, all these are examples created for this purpose. Let's start with the first program. What first program has to say? Python1.py, and this is a quite simple program. What this program is doing and how it is working, let's understand. Import required libraries first, that is MySQL Connector. This is the library which helps you in connecting to the MySQL server. Now you created object, we call it as a connection object, like say database. You give it any name does not matter. What matter is the parameter, how you pass all those parameters here. So MySQL.connector.connect. Now you specify the host name, like if it is localhost, you specify localhost. If it is the IP address of a remote machine, you specify the IP address of the machine, username, password. You can specify more parameters like database name and other things. So we are passing bare minimum 3 parameters, that look, this is the username, this is the host name, and this is password. Now show me all the databases. Show me the object first, that what you got, whether it's successful or failure, show me the status, and then disconnect it. So it is just doing one step, that is connecting and disconnecting and displaying the information. So when you run it, you just got the details of the connection context, and the connection is created. This is the connection object ID. That was a quite simple program, connecting to Python, connecting to MySQL from Python. No data reading, nothing. Let's look at the second program, little more. Now what we will do inside this: import MySQL connector, database, hostname, username, password. This will be everywhere now. That means first 5-6 lines you should understand that will have database connection details. After that we are going to work with the database related objects. So prepare a cursor object. By definition, cursor is placeholder for a result set. The result which you might be inserting in the database, results which you might be fetching from the database. So cursor object, we create cursor object database.cursor. Now we are creating a database. Create database, the Skillpedia. And then look how we are passing the statement. We are directly passing the query, create database, the Skillpedia. Disconnect from the server, database close. Let's create the database with the name Skillpedia. This object, whenever you create an object, the concept of object and classes have corresponding methods and variables and parameters. We are defining the cursor object here, database, same database, cursor object. We are passing the query to this execute to the cursor object, and then we are closing the database by calling the close method. This will close the database and it will create a database with the name Skillpedia. This is second program. So what you can expect, no output, but it will just create the database. Let's verify. Show databases. And you will see the Skillpedia earlier created. I changed the name today just to create another database right now. This is created just now, Skillpedia. Now next, let's go on to the next program. That is third program. And things will start repeating, you will start realizing connecting. So database creations, right? But here we are providing the database name also. I am changing the name because I want to work with the new database, not the old one. That I created for the preparation of these contents. But now as I work, I am changing the database name. I created just this Skillpedia database I created in the previous step, previous program. So I am passing the database name also. Now same process, prepare the cursor object, and now I am going to create a table. Creating a table. So I first write the query, student record. And this is here document in in Python. We know that whatever you put in triple quote, that will be taken as it is, right? So this is nothing but a create table statement, what we use in MySQL, and then execute it, execute student record and disconnect it. So by the end of this, you specify it here. Now therefore what will happen when you run this program? Table will be created. Let's verify. The table student is created. So we got the table structure what we created. Let's move on to the next program, program number 4. What this program is doing? Same process, table creation, database. I'm changing the name. I just created one table. Preparing the object, insert into. So we are inserting a record in the table student. These are the fields of the table. I define SQL as a variable, as an object with this query, and it's continuing values in this format. And what I want to pass, Yao CSC 85B29, that is name, branch, roll number and section and age. So I'm passing these values and this value will be executed. And then execute this SQL with these values. The placeholder %s will hold the value Yao. This %s will hold the value CSC. This %s will hold the value 85. This %s will hold the value B. The order has to be the same. And if you remember, we have different placeholders. We discussed in initial lectures the data types and corresponding placeholder, %i for integers, %s for strings, if you recollect that. So this is the placeholders. So this will hold the value Yao. So whatever value we specify, that will go in the right place. Which is we are passing here, SQL and then value. So this is a continuous statement, and statement terminate here. This value, this is actually continuation. If you look at here, this is actually continuation here, like this. Yeah, these are the values. So we are passing the query SQL, and we are passing this placeholder values actually. This %s and all these value corresponding values are provided here with another variable which we are supplying here also. So SQL and the values are provided. When you commit, this is your commit method of the database object, means write them to the database as we know what the definition of commit is, and close it. So let's see 4 program, and now again log in and check, select star from student, and this is what we entered through Python. Got it? Now let's look at the next program, program number 5. So what it is doing, computer science, just a subject name, branch. I mean a hypothetical scenario of students in a class, in a table, student table. And now that was one record. This is multiple values, inserting more values together. So all these records will be inserted. There is no other difference if you look at this particular program. No other difference apart from that we are entering multiple records. Rest of the program remains the same. You understand? So let's insert them multiple values. Other than that, apart from that, there is no difference. So let's look at the next program, program number 6. What this program is doing. This is now, before this program, what I was doing is I was logging into MySQL, showing you the outcome. Now I'm doing the this part, next part, through the program only. And I'm sure there is no confusion, there should be no problem in this, that up to here the same thing, preparing the cursor, and this is the query, select name, roll number from student, execute the query. So wherever the results are stored, this is all cursor object fetch all. Fetch all means get all the values. Fetch one will get one record. So my result will store all the results. If there are 20 records, it will fetch 20. If there are 5 records, it will get all the 5 records. So therefore you have to use loop iteration we discussed. For X in my results, print X means it will print all the records one by one. The output of this query. You got my point? Let's see. Program number 6, and you see these are the records. So we are able to display the records also from the database. Let's look at the program number 7. What this program is doing. Now you guide me, you suggest me what this program will be doing. It is updating your records and will change your age from 28 to 23. It is making you more younger. Alright, and you can check that. So let's save and execute this. Earlier your age was 29. You see, from 29 it will make you 23-year-old. Let's execute. No, young. Now you see the age is changed 23. Got it? So next is program number 8. What this is doing. Now you have to take it forward. You just start guiding me that yes, I know what this will be doing. Exactly. Do I need to execute? Yes, let's execute. So it will drop the table. Next program number 9. What do you think what this program will be doing? We are using the same fetch all method. But only thing is that this time we are going a little more advanced and we are using a for loop and we are adding field from this result. Okay, because we are fetching all the results are there into a results array, right? And we are getting into a row as single record. So row 0 will be the name, row 2 will be the branch from here, row third element will be roll number, fourth element will be section, fifth element will be age. I need only first 4 elements. I mean first 5 elements, right? 0, 1, 2, 3, 4. Yeah, first 4 elements. And then I'm displaying with a proper message, print name is %s, branch %s, placeholder, and I'm supplying those values here. Again, concept of placeholder. The name will be placed here, branch will be placed here. You understand? So this is a better way of, sorry. From this part. A for loop is simple. For loop is for row in results. This results may be multiple records, correct? There might be 10 records. So we are fetching all of the records. All those records, visualize them. No, they visualize them in the form of a table. So this is a table and a row in the table. Now since we are taking one row at a time, so what we will have in the one row? We will have columns. So what will be the first column? Row 0, because it is array, it is list if you look at. So row 0 will be the first element, which is in order here. Name. Row 1 will be what? Row 2 will be what? That's what I'm assigning. These are new object I'm taking. I'm fetching them into variables. And now I can manipulate this. I'm just giving you direction that look how you fetch the values from a database into variables, and then you do whatever you want. Individual values, and then you send them back to the database. We are slowly and steadily building advanced concept. In fact, I'm using try catch also, exception handling also. Got it? So let's do it. So where the database was, fourth added 1 records, fifth added more records. Now we have the table back, we have all the records back. And now we can execute this next program, that is 8. This was the 8th program, right? No, 8th, no, not 8th one, 9. This was the 9th record, right? 9th program. Let's execute this 9th program. And this is what I was saying. First record, name Yao, branch CSE, roll number 85, section B, age 29. Got it? So we are fetching record by record. So let's move on to the next program. Program number 10. What this program is doing? Look at carefully because there is only one difference, and that is two minor difference. Fetch one row, because earlier I used fetch all, and I am not using any loop because I am reading one record only. You got the point? Only that is the difference. Apart from it is same. No loop. Single record with fetch one. And now you see. So you will get one record. Record fetched 1. And this is the record. Program number 11. What is this program doing? CSV, comma separated list, filled. Filled will be these rows. You supply the list of rows, individual list separated by comma. List 1, list 2, list 3, list 4, list 5, right? And file name. This file will be created. How? We know how to create file with open file name in write mode, add CSV file. Got it? And then we are using CSV writer and CSV writer. CSV writer, we have CSV reader also. Writer will write the record. Reader will read the records. So what we are writing? We are writing the fields, and then we are writing the rows. In other words, this program will create a file with the name collegerecords.csv, and it will dump these records in that file. So it will create a CSV file. If I have the file, I need to remove this. The file already created earlier. I am removing this file. So let's run the program number 11. And file is created again. And let's check the records. Yes, the fields and the corresponding values. CSV file is created. Right? Let's move on to the next program. Program number 12. What do you think what it is doing? Exactly. So you are specifying the field, but then what is the difference between this program and the old program? This time what we are using, look at carefully, we have to be very, very careful. We are using dictionary. Earlier it was list. So earlier we supplied the fields in one separate record, but this time we are supplying the field name with every record, because the dictionary concept is we have the key value pair. Key is the column, value is the actual record, right? So every time we are supplying the same column name, and that's what we are saying here: name, branch, year. These are the fields. So it will fetch only those values from here which are corresponding to name. So name is here. Then branch is here. Then year is here. Then next is CGPA is here. So it is not going to take anything else. So we are fetching the keys and putting them as fields in our CSV files. The rest is same. Writer writing the headers and writing the rows. But important point, carefully, very carefully, write rows, the dictionary, because here we are using the dictionary. This is my dictionary. Alright, so this will create school records. Let's remove school records.csv and let's execute this 12, and let's check what is created. You see, we got the file created. A school record CSV file is created. Next program number 13. What do you think what this program is doing? The file name we are supplying, fields and rows, empty lists are created. Now we are reading with open file in read mode as CSV file. We are reading. I told you, we have two methods, reader and writer. Reader will read from the CSV file, writer will write to the CSV file. Previous two examples were writers. This example is reader, right? So fields, and then display all the fields one by one and count total number of fields and display them, and we are displaying records one by one. So this is quite simple, straightforward. Let's run this program number 13, and we got 5 records. Total records 7, total rows 7, fields are, we fetch the fields and then field are displayed one by one. Alright, all the 5 records. Then next program 14, what this program is doing. Simple program. It is importing request, that is for JSON data fetching. Fetching the data from HTML pages, web pages. So what is the URL? Skillpedia all courses. Get the URL and print the content. So it will print the content of all courses page from this website. Python program, alright? Let's do this very quickly. I'll show you once again. I'll open that once again. And it will fetch the data from the Skillpedia and it will display, throw the data here. It is not readable. We need to make it beautiful. We need to parse it. That is the next example. So let's read once more. You are saying what is R? Donkey, horse, monkey. It is just a name of what? Request.getURL. Means this is a class. We are creating object and we are using get method from this request library to pull the data from the URL specified and dump the content into R object and then print the content. Yep. Right. Let's look at the next program 15. Similar but better. Only you have to see the difference part. Same, what we need to do. We are importing requests, and this is another beautiful library, BeautifulSoup. Rest same. It will beautify the data. Same request get URL, but we are using BeautifulSoup content HTML5 lib. If this program is not there, you have to install it using pip install HTML lib, or that library, presentation will explain that what all software you have to install and why and how. But yes, if we run this program number 15, you will see the data, not all these tabs, HTML tab, but little better way, better presentable way. I'm going to share all these programs with you. Now I can start the session once I get the output of this. See, it is more presentable with proper aligned div HTML. You see, it is not the junk of text. So let's start the program, because there are a couple of more programs. If you see, we are on program number 15 and we have program up to 19 or 20. I'll leave the rest of the programs to you. Working with the data and databases in Python. Relational databases, MySQL, CSV data, getting data from web. I demonstrated examples up to here. This example I leave it to you, which is there. 20 programs I'm giving you. All I'm going to explain here. Persistent data. Many software solutions require persistent data. By definition, persistent means which stay on the disk, which can be used later. That is data stored permanently. There are many ways to have data persist, like text files, for example, comma delimited files. Object binary files, for example, using Pickle, or databases like SQLite or MySQL or Microsoft SQL. There are libraries available for every database. A database or database management system manages persistent data. DBMS allows data storage, retrieval, privacy, security and integrity, which you are expert of. Many commercial and open source examples available like SQL Server, Oracle, Access, DB2, SAP ASE, MySQL. These are open source. PostgreSQL, SQLite, Percona, MySQL. These are open source databases. Now, how do we connect? What Python has to handle? How Python handles these databases? There is a library called Python Connector. So, to access MySQL database from Python, you need a database driver. MySQL Connector Python is a standardized database driver provided by MySQL. So this is Python driver which will connect to your MySQL database directly and which will fetch the data from your MySQL database. Supports almost all features provided by MySQL version 5.7, of course 8 also. Allows you to convert the parameters value between Python and MySQL data type, for example Python datetime and MySQL datetime. It converts those data types. Obviously, when you will be dealing with real data, you may have to do the transformation of the data, change the data types field by field if the data types are not matching. It supports all MySQL extensions such as limit clause, cursors, allows you to compress the data stream between Python and MySQL data server using protocol compression. Supports connection using TCP socket and secure TCP connection using SSL also. It's an API implemented using pure Python. It means that you don't need any extra library, MySQL client library or any Python module except the standard library. The connector versions, MySQL Python version and MySQL server versions and supported Python versions. If you are using connector version 8 and MySQL version, all these versions are supported. Python version supported for this are 3.6, 3.5, 3.4, 2.7. If you are using connector version 2.2, it will support MySQL version 5.7, 5.6 and 5.5. Python 2.7 onward will be supported up to 3.5, not 3.6. Similarly, if you are using old version of MySQL, old version of Python 2.6, that will be supported by 1.2 version of Python connector. So connector version, MySQL version, connectivity comparative, this compatibility table is very important to make you understand that which MySQL version we are using, which connector version we are using, whether it will be supporting this Python version or not. This table will help you in assisting that. Installing, quite simple. You have to be the root user and Python installed on your system. MySQL connector installation require Python to be in the system path, otherwise it will fail. The MySQL Python connector is available on this website pypy.org. Therefore, you can install it using pip3 command. The pip3 command allows you to install this connector on Windows, Mac, Linux or Unix, and this is how you install it. pip3 install MySQL connector Python, and this is the screen grab when I installed it on my system. You see the same screenshot, session 16, pip3 install MySQL connector Python. You can also explicitly specify the module version which you want to install. So MySQL connection Python connector Python equal to 8.0.17. To uninstall the current version, you can use pip3 uninstall. So this is installation and uninstallation of Python connector. Verifying the connector installation. After installing the MySQL Python connector, you need to test it to make sure that it is working correctly and you are able to connect to the MySQL database without any issue. So here we go. We are trying import MySQL connector. MySQL connector.connect. Now host name, database name, username, password, and you should get the database object. We are trying the things out at the command prompt only, Python prompt, and you will get the database object, connection object. Verify MySQL connector using a program. This is your first program we have gone through. You can also verify with a Python program. Import required libraries, provide the details, print the database object. That was the object which displayed in the previous slide, and disconnect. Creating database, we created in program number 2. For this we will first create cursor object and then pass the SQL command as a string to the execute method of this object. The SQL command to create a database is create database name. So therefore open another tab, connect to MySQL server and verify. So first tab we are writing the program. Import the connector, define the object, prepare the cursor object, create the database and disconnect. In another tab, verify it, the database is created. Because here we are creating the database, the Skillpedia. The Skillpedia was created. Indeed, you notice the database existed. Creating tables. Quite simple now. So you create a table. Now you're finding it very easy, and verify in another tab. Inserting data in tables, database, prepare the cursor object, define the SQL values, and then execute, commit it, close the connection, verify in another tab. Inserting multiple rows is possible. We did that by defining list elements. We defined multiple elements and then we inserted all the elements in one go. Verified in another table. That was program number 5. Read data from MySQL table using Python. You can use either fetch1 method to fetch a single record, or you can use fetch all to fetch multiple values from the database table. Fetch1, it fetches the next row of the query result set. A result set is an object that is returned when a cursor object is used to query a table. Fetch all will fetch all the rows in the result set. If some rows have already been extracted from the result set, then it retrieves the remaining rows from the result set. And row count will tell you how many rows were executed, will returned or fetched. And this is same, one by one executing. Fetch all and displaying them all with loop. And you got the output. This is using in a better way, updating the query. Another record, update student, set age 23, where name is Yao, and then verify that. That was program number 7. Because it is simple, same now, because up to here I am not changing anything. This is also same, only this part is changing, and how after that last 2 rows are also same. Why I am giving so many examples? Because I want you to try all of them one by one, so that by the end of the this practice of these programs, you are more confident in handling the database, creating tables, inserting data, updating data, fetching rows, all the records one by one, field by field, everything. Drop table in MySQL. Simple query and commit. Verify. Exception handling can also be done, which was demonstrated here. We use try catch. So if there is any error, try creating some error here and you'll get the exception handled properly. Unable to fetch the data. Try giving a wrong database details or something. That is exception handling can also be done. In production level, we use exception handling. Without this, we never work actually. Because we can't Python specific error messages to be displayed to the duffer user. Because we always treat user as a dumb duffer without any knowledge. So he can type anything. So we have to display him meaningful message. Sorry, I am not able to fetch the data. So that is readable right message to be displayed to the user. This is another again exception handling, but this time it is fetch one. The previous example was fetch all. That's the only difference. Fetch all use the for loop. This is not using any loop because we are fetching one record. Performing transactions. Transactions are a mechanism that ensures consistency. Transactions have these four properties: atomicity, that is the acid, you know that, atomicity, consistency, isolation and durability. Any serious database user know these features. Python database API provide two methods, commit and rollback for the transaction. This is transactional statement in Python. Like you commit, if you want to roll back, if there is exception handling, so transaction failed, rolling back, error was, you print the error message and then you roll back. And you can also use another exception here, unable to roll back. The error was, you display the error also. CSV module. The CSV, that is comma separated values format, is the most common import export format for spreadsheet and databases. The CSV module implement classes to read and write tabular data in CSV format. We have a readers and writer object. Reader will read the data, writer will write the data, that is sequences. Programmers can also read and write data in dictionary form using a dict reader or dict writer, dictionary reader, dictionary writer classes. For working CSV files in Python, there is an inbuilt module called CSV. So therefore we need to import it. So importing CSV, defining the fields, defining the rows and the file which we want to create, and then we are using CSV writer. So we are writing in the form of list. If you are using dictionary, we will use a dictionary writer. So fields are list containing the field names. Rows are list of lists. As I said, list of lists. Each row is a list containing the field values of that row. With open file name W as CSV file, CSV writer and write to this file. So we first open the CSV file in write mode, that is W. The file object is named as CSV file. This is specified here. The file object is converted to CSV writer object by using this CSV writer object. We save the CSV writer object as CSV writer. We are writing it here. We use the write row method to write the first row. Write row method to write the first row is nothing but the field names only, and then we write the data. So write rows, write row, fields will be written first, fields, write row fields and write row rows. So first this statement will write the fields in the CSV file and this will write the records in the CSV file. You can also use dictionary. The file object CSV file is converted to dictionary writer object. How? Where? It is here. Dictionary writer. Dictionary writer, CSV file, field name are taken from fields. These are the fields I am giving. So field names are from fields, and we are converting that into dictionary writer, and then we are writing. Writer.write rows my dictionary. That is this dictionary. So we specify field name as an argument. That is writer.write header. That will write the header. So write header method simply write the first row of your CSV file using pre-specified field names. And then writer.write rows my dictionary. Write row method simply write all the rows, but in each row it writes only the values, not the keys. So this is dictionary formatted data written to CSV file. Reading from CSV file, quite simple, we use CSV reader. We extract fields, and then for each row in CSV reader we are fetching the value. Getting data from the web. There are mainly two ways to extract data from the website. Use the API of the website if it exists. For example, Facebook has Facebook Graph API, which allow retrieval of data posted on Facebook. Access the HTML of the web page and extract useful information from it using filters, regular expressions. This technique is called web scraping. This is what Google does to populate the data to create the database. We shall use web scraping framework of Python called BeautifulSoup. Steps involved in web scraping. You send HTTP request to a URL of the web page you want to access. The server responds to the request by returning HTML content of the web page. For this task, we will use a third-party HTTP library, that is Python requests, and we imported requests. Once we have accessed the HTML content, we are left with the task of parsing the data. Since most of the HTML data is nested, we cannot extract data simply through string processing. One need a parser which can create a nested tree structure of the HTML data, which we have seen. There are many HTML parser libraries available, but the most advanced one is HTML5 lib. Now we need to do is just navigate and search the tree we created, that is tree traversal. For this task, we will be using another third-party library, that is BeautifulSoup. It is a Python library for pulling data out of HTML and XML files. So requests, HTML5 lib and BeautifulSoup. These are the requirements. We need to install. Step 1. Install the required third-party libraries. All you need to do is this: install request, install HTML5 lib, install BS4. If you are using yum command, you can use all these commands. Yum install Python request, that is global, system wide. pip3 will use for only specific user. That's the difference. So install for global, for the system wide installation, yum install Python request, Python 3 request, BeautifulSoup, and show BeautifulSoup will show you. Now you can access the HTML content from the web page that was demonstrated in program 14. Import requests, specify the URL and dump the data. I showed you this data. First of all, import the requested library. Then specify the URL. Then send a HTTP request to the specified URL and save the response from the server in a response object. Let's say R. And then r.content will get the raw HTML content from the URL. Parsing the HTML, for that we require BeautifulSoup. And then we use HTML5 library. So BeautifulSoup, content, HTML5 lib, and we got a proper indented and proper parsed data. from our page. Parsing the HTML content. The BeautifulSoup library is built on the top of HTML5 parsing libraries like HTML5 lib, LXML, HTML.parser, etc. So BeautifulSoup object and specify the parser library can be created at the same time. For example, this is what we did. BeautifulSoup, the content, that is raw content, and HTML5 library. We create a BeautifulSoup object by parsing two arguments. First was the content, that was raw HTML content. Second argument was HTML5 lib, that is we specify HTML parser we want to use. Now the last line was soup prettify is printed to give the visual representation of the parse tree created from the raw HTML content. That's what used in the last statement to print this. Print soup.prettify. Step 4. Now you can do searching and navigating also through the parse tree. The last step, which will make you more advanced, perform advanced options in that. So you can use filters. Now we would like to extract some useful data from the HTML content. Obviously tags are of no use to us when we are talking about the data. The soup object contains all the data in the nested structure which could be programmatically extracted. In our example, we are scraping a web page consisting of some quotes. We would like to create a program to save those quotes, and this program will save those quotes separately in a file. We are going a little more advanced now. Request BeautifulSoup import CSV, which means we are going to save those quotes in the CSV file. Fetch the data from this URL, raw data, beautify, and we are creating an array or list object, list to store the quotes. So find div all quotes, because this is the identification where my quotes are, under what ID the quotes are stored. That is HTML tag. These are the attributes. So we want to search all the HTML tags where the ID of the tag, class of the CSV tag, CSS tag is all quotes. And then one by one fetch all the rows and drop them, put them into the table. Create a row and then write them into the CSV file. Open this file and write the data. So this is the advanced program which is parsing the records from parsing that content of a web page, filtering or extracting meaningful data out of it, and then displaying it. Let's understand what this program was doing. All the quotes are inside the div container whose ID is all quotes. Therefore we use this. So we find the div element, term the table in the above code using find method. This was the use table equal to soup.find div attribute ID all quotes. The first argument is HTML tag you want to search. You want to search div, you have to specify div. And the second argument is the dictionary type element to specify additional attribute associated with that tag. So find all the div where the ID of the tag is all quotes. Find method returns the first matching element. You can try to print table prettify to get sense of what this piece of code does. Now in the table element, one can notice that each quote is inside a div container whose class is quote. So we iterate through each div container whose class is quote. Then we use find all method, which is similar to find method in terms of argument, but it returns a list of all matching elements. Each quote is now iterated using variable called row. The full form of JSON is JavaScript. Now the next topic, JSON, last topic, JavaScript object notation. It means that a script or executable file which is made up of a text in a programming language is used to store and transfer the data. Python supports JSON through a built-in package called JSON. To use this feature, we import JSON package in Python script. The text in JSON is done through quoted string which contains the value of key value mapping in curly braces. This is similar to dictionary in Python. JSON shows an API similar to users of standard library Marshall and Pickle module, and Python natively support JSON features. This is a simple example of JSON data. Program number 17 of the source code. Import JSON. Define the object. Name is John. Age is 31. Salary is 25,000. Conversion to JSON done by dumps function. B equal to JSON.dumps A, and print the output in JSON format. This is what the JSON format look like. Name, age. As I said, similar to dictionary in Python, because JSON format is same, except that you can have nested data, nested elements. Means this value, age, can be a nested element of another JSON data. As you can see, JSON support primitive types like string and numbers, as well as nested list, nested tuples and objects. Now here you will see the examples. Import JSON, print JSON dumps, welcome to the Skillpedia. So you will see individual element. So welcome to the Skillpedia, this is supported. Means JSON dumps supported the list type. Then conversion to array, print JSON dumps, welcome to the Skillpedia. String conversions to string, print JSON dumps hi. One by one you see all the values. So it is trying to convey the message, look, you can have list, you can have strings, you can have numbers, you can have boolean values, true false values, null values, everything. So it supports all these types. JSON module. Serializing JSON. Serializing means fetching individual values, parsing through the elements one by one. The process of encoding JSON is usually called serialization. This term refers to transformation of the data into a series of bytes, hence serial, to be stored or transmitted across a network. To handle the data flow in a file, the JSON library in Python uses dumps function to convert the Python object into their respective JSON object. So it makes it easy to write the data to the files. Consider the given example of a Python object. Suppose this is our object, where subject math 85, physics 90. Encoding this using this dem JSON. Storing marks of 3 subjects, where, and then print dem JSON encode where. This will encode the data. The decode function is used to convert JSON object into Python format type, vice versa. So we use decode, self and object. Decoding using JSON object. This is example, where value A0, B1, C2, D3, E4, and I want to convert or decode it into Python data type. So we use decode. So from Python to JSON we use encode. From JSON to Python we use decode. We can also use encode through iterencode package, method for encoding, other method. This is another method, JSON encoder, encode, and similarly decode. Sorry, for I we are iterating through it. So for I in JSON encoder, iterated encode, iterate, or let's say iter encode means iterate encoder object and write them to the socket. Socket basically we will learn in socket programming to transfer the data to remote machine, and that's what the serialization is used for. Can also have command line uses. JSON library can also be used at the command line directly to validate and print your JSON. Like echo, this is simple JSON data and you can print it. You will get the output, printed output directly in JSON format. That's all for this session 16. It was comprehensive sessions. We discussed 3 different data handling: persistent data, JSON data, web data parsing, and MySQL databases. 3 on CSV data. 4 different data handling techniques we learned with examples in this session. Thank you.